Hello and welcome to this video. In this video, I will be giving a brief introduction to RxJava 2.0 and also look at some of the terminologies which we will be using throughout this course. Now, what is RxJava? Rx stands for Reactive Extension. Reactive Extensions is a library for writing asynchronous and event-based programs. It is very similar to the event-driven approach used by Node.js. Microsoft created the first reactive programming framework for .NET called Reactive Extensions. The Reactive Extension port for Java was done by Netflix and released in the year 2014. Now the question arises, why to use RxJava? We can see in our everyday life that whatever actions we perform are initiated by some kind of event. This is called reactive approach. Similar approach is followed by RxJava. Asynchronous programming was previously possible in Java using interfaces and callbacks. It made the code look clumsy and hard to read and debug. With the introduction of Rx approach, asynchronous programming in Java became a lot more easier. Asynchronous programming means you have to deal with threads, and thread management became very simple with RxJava. We will learn about thread management in great detail in forthcoming videos. RxJava also gave inbuilt support for caching of data, which helps in reducing network calls. Now we will briefly discuss some of the terminologies used in RxJava. Don't worry, we will discuss each of them in great detail in forthcoming videos. Observable. Observable is something which emits some values, items or events. So observable is actually the source of data for an observer. The observer is the one who receives these values and performs some action based on the received data. A subscriber is actually an implementation of the observer. An observer needs to subscribe to an observable in order to listen to its emissions. Operators. Operators act as mediators between observable and observer. They modify or filter the data emitted by observables before it reaches the observer. RxJava 2.0 introduces flowables. Flowables are very much similar to observables. The only difference being that it supports back pressure. Back pressure is used to control the rate of emission of an observable. It might be possible that an observable is emitting data so fast that the consumer is unable to keep up with the flow and hence back pressure is required. Single, completable and maybe are types of observables and we will discuss them with examples later. Disposable is an interface used to dispose of subscriptions. It might be possible that the observer is no longer interested in the observable, so it needs to dispose of the subscription to stop listening to the observable. If you have more than one disposable, you can bundle them up into composite disposable and dispose all at once instead of disposing them separately. Thanks for watching.